guys, greetings. Uh, Welcome back to Study with Mo. Today we're gonna review the October and November 2024 paper Chemistry 062042. First question starts with a simple letters. The formula of the molecules A to Y are shown in table 1.1. Molecule A, C2H4, B, and blah blah blah. So answer the following questions about the molecules A to I. Each letter may be used once, more than once, or not at all. State which of the molecules A to I is an element with a triple bond. So what we're looking for here is, remembering the syllabus, it said that it clearly stated the examples of the molecules that have triple bond, double bond, and single bond. So the most notable one here is nitrogen, so we just find for nitrogen and 2G, G. We remember we only can do the letter. They just do the formula here so that you can know what molecule or what formula the letter signifies. Is a product of photosynthesis. We know that both oxygen and glucose are the only products. So let's see, for oxygen, H is used as a fuel, ethanol, B, C2H5OH. You need to remember the molecular formula for these notable compounds. We got turns lime water milky. That is the test for carbon dioxide. DCO2 undergoes a substitution reaction with alkanes. This is a bit of a tricky one. So undergoes a substitution reaction with alkanes. We don't really know, but if you review properly in the last chapters about alkanes, alkenes, polymers, you remember that there's a photochemical reaction, and that photochemical reaction includes the chlorine with the alkanes. So we would choose chlorine here. E is a colorless liquid at RTP. We know that ethanol is the colorless liquid at RTP. So B is unsaturated. So that means it has double bonds. And which homologous series has double bonds? That's right, alkenes. So C2H4, if you look at the general formula, CnH2n, so that's an alkene. Is 21% of clean dry air. We know that it is oxygen. H is a reactant in the Haber process. We know that nitrogen and hydrogen react to form ammonia, so we know that it's either N or H here, so Ng. 2. Aluminium is manufactured by the electrolysis of aluminium oxide. State the name of the main ore of aluminium. We know that the main ore of aluminium is bauxite. For iron, it's hematite. Name the substance mixed with aluminum oxide to reduce the operating temperature of the process. So that substance is cryolite. And remember to not mix up the that substance with the main ore of aluminum, because they both have like a similar notation. Explain why the molten mixture in B conducts electricity. That's going to be mobile ions and not mobile electrons. Why? Because it's a mixture. Table 2.1 contains some information about the process which take place at the anode and the cathode. So at the anode, they want to refer to the reaction. So that's going to be 2O2 minus 2O2 plus 4E. And for the cathode, aluminum is going to be aluminum. Complete table 2.1 already. State why the process at the anode is an oxidation, because we are losing electrons. Oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide and not oxygen. That's because carbon anodes react with oxygen to form carbon dioxide due to high temperatures. State why aluminum is used in food containers. Because it's resistant to corrosion. It's not because it's non-toxic. Aluminum reacts with fluorine to form the ionic compound aluminum fluoride. Complete the dot and cross diagrams in figure 2.1 of the ions in aluminum fluoride. So what you should do here is basically complete the outer shells with 8 electrons. For metals, it's going to be simple. You just complete with the X's. And for the non-metals, just remember not just all of them are circles, just include the 1x there. You also remember to put the charges, that's one mark, and to also make a neat drawing, not necessarily very neat, but neat enough to be understandable. Sulfur forms two chlorides, P and Q. Chloride P has a formula S2Cl2, chloride Q has a formula SCl2. Both chlorides are covalently bonded and have low melting points. Suggests in terms of attraction between particles why these chlorides have low melting points. So they have low melting points because they both have weak intermolecular forces of attraction between molecules. You have to say between molecules because apparently in the mark scheme it says between molecules. Chloride P S2Cl2 forms when sulfur reacts with chlorine. Write the simple equation for the reaction. For this reaction, 2S plus Cl2 equals to S2Cl2. Remember to just write it first as, without the numbers at the coefficients, but I remember to do the Cl2, the subscript, because chlorine is a diatomic element, diatomic molecule, so you have to remember that. Complete the dot and cross diagram in figure 3.1 of molecule of chloride Q as Cl2. Show outer electrons only. Yet another drawing question, but this time simple because it says show outer electrons only. What you gotta do is just complete the circles and the crosses. The circle, you should assign each element its own shape. So for chlorine, because there are two chlorine atoms, so the shape must be the same circles and not, for example, triangles or boxes. And sulfur, it's just X's. And remember that sulfur originally had 6 outer electrons. Chlorine had originally 7 electrons. So they should be the same number. What is different is that they are sharing now 2 electrons for each other. Chloride P is converted to chloride Q by reaction with chlorine in a closed system. The reversible reaction reaches an equilibrium. P plus Cl2 equals Q. Forward reaction is exothermic. So take a note, or you can also say that if the forward reaction is exothermic, you can also make a side note and say that delta H is negative, or you can say less than 0. Suggests 2 changes to the conditions which will result in a decrease in the concentration of chloride Q at equilibrium. So increase in temperature, because if we know that the forward reaction is exothermic, that means to make it the reaction in favor of 2SCl2, we decrease the temperature. But if we increase the temperature, we're gonna favor the reverse reaction, which is endothermic. So we're gonna increase in temperature because we want to decrease in the concentration of chloride Q, and also to decrease the concentration of P. Why? Because Le Chatelier's principle says if there's a movement or there's a cause in a certain point in the reaction, there will be another movement or cause that will oppose that movement. So if we decrease the concentration of P, Q will also decrease in concentration to counter balance the reaction. Kinematics. The rate of the forward reaction in D is determined by collision theory. The rate of reaction depends upon 2 factors: the frequency of collisions between particles and the proportion of collisions which have energy greater than or equal to the activation energy. So define the term activation energy. It's basically the minimum energy required for a successful collision. Give a symbol for activation energy: E capital and lowercase a subscript. Complete table 3.1 to show the effect, if any, when the conditions are changed. Use only the words increase, decrease, or no change. So the effect on the frequency of collisions between particles and effect on the proportion of collisions which have energy greater than or equal to the activation energy are actually 2 different things. So the frequency of collisions between particles are basically what is affected by temperature and affected by the concentration. But the proportion of collisions which have energy greater than or equal to the activation energy is basically measuring the particles themselves, not just the collisions that have energy greater or equal to the activation energy. So obviously, if you increase the concentration to whatever amount, the energy will not change. But if you increase the temperature, you're increasing the kinetic energy, which is increasing the average which is increasing the proportion of collisions, which is increasing the number of collisions between particles, which also leads to a greater proportion of collisions which have energy greater than or equal to the activation energy, as well as a catalyst, because a catalyst reduces the activation energy, as you read in the syllabus, that it provides an alternative pathway for the reaction, which consequently decreases the activation energy required for a successful reaction. The reaction of chloride P with chlorine is a redox reaction. P plus Cl2 equals to SCl2, same as the old one. The oxidation number of Cl and chloride P and chloride Q is -1. Use oxidation numbers to explain why sulfur is oxidized in the forward reaction. So as we can see, Cl2, we know that Cl has -1, so -2 plus 2x equals to 0. So that's going to be 2 divided by 2. X is going to be 1. So sulfur before the reaction was +1. Sulfur after the reaction, let's see. So negative 2x, 1x, so x minus 2 equals to 0. So x equals to 2. So that means S has now an oxidation number of +2. Because as you can see, we're using the compound oxidation number to determine the oxidation number of the constituent elements, which are S and Cl. Chlorine is oxidized in the reverse reaction. We use the same technique, so it's going to be basically the oxidation number increases from -1 to 0. 4. Silver bromide. This is, I believe, a separation techniques question. In fact, this is crystallization. This is precipitation. So silver bromide (AgBr) is made when aqueous silver ethanate is added to aqueous sodium bromide. So silver bromide is, what salt is that? That is an insoluble. Salt. How do we know? We refer to the table in chapter 11 or chapter 10. It looks at which salts are soluble. For example, nitrates. All nitrates are soluble. Chlorides not really, because we got silver and lead, which are insoluble. So since it's silver bromide, doesn't change the because bromine, and chlorine are in the same group, so basically they have the same properties. So if silver chloride is insoluble, so silver bromide must be insoluble too. Alright, so they show us the equation for the reaction, which is CH3COOAg plus NaBr equals to CH3COONA plus AgBr. So it says that they added a specific volume of silver ethanate to the beaker. So we know that silver ethanate is aqueous, and basically they show us the method. Alright, complete the ionic equation for the reaction by adding the missing state symbols. Ag should be aqueous, Br aqueous, they literally said that it is aqueous. To AgBr, so AgBr, it doesn't tell us. Wait, it actually tells us a precipitate forms, but we're not sure. But still, AgBr, if we refer to that chapter of salts, solubility of salts, we know that it's going to be solid. Name a different aqueous silver salt which could be used in step 1. So in step 1, it will be silver nitrate, because all nitrates are soluble. Use the information in step 2 to calculate the concentration of aqueous NaBr. So we know the moles are 0.01 over the volume. The volume is going to be 200, so 200 over 150. So it's going to 50 over 1,000, 0.01 over 50 over 1,000 equals to 0.2 moles per decimeter cubed. State the color of the precipitate which forms in step 2. As you can recall, if you recall in the ions or negative ions, anions table, anions test table, you should memorize that that the Br gives cream and chlorine gives white, while iodine gives yellow. So say the color of the precipitate which forms in step 2. Since it's bromine, it's going to be cream. Use the information in step 1, step 2, and equation 1 to determine the number of moles of AgBr formed. Use this value to calculate the mass of AgBr formed. So the number of moles of AgBr is 0.01. It literally tells us here 0.01 of Br minus ion, since the Ag and Br ratio are the same, 1 to 1, so it's going to be 0.012. What is the mass? We calculate the MR, which is 188. 188 times 0.01 will give us 1.88. Name the salt dissolved in the filtrate in step 3. So there must be two compounds actually made, but they just gave us this. This is the ionic equation. And the ionic equation only gives the important part, what really happens, not really the spectator ions or spectator molecules. So it's going to be AgBr and also sodium ethanoate. So the recorded mass of the dry residue in step 5 is greater than the mass calculated in E because a step is missing from the procedure. Suggest a missing step. So here they said dry the solid residue until all the water is removed. Filter the mixture. We have a step missing here, which is rinse the residue. Then you dry it and repeat the drying method until constant mass is achieved, so you are sure that all the water has disappeared. Name the substance responsible for the greater mass of the dry residue. It said dry residue, so sodium ethanoate, but crystals in its crystal state, because sodium ethanoate is soluble, so we don't know if it's aqueous right now, if you're talking about the aqueous one or the crystals. But in the mark scheme, it doesn't really emphasize on the crystals part. Barium sulfate can be made by the same method but with different aqueous solutions. So it suggests two aqueous solutions which can be added together to make barium sulfate. So you got barium nitrate, soluble, and potassium sulfate. They both have to be soluble and they both have to include barium and sulfate at the same time. Write the balanced symbol equation for this reaction. So BaNO32 plus K2SO4 equals to BaSO4 plus 2KNO3. The second one can be any metal that is soluble with sulfate. But usually potassium, sodium, and ammonium are the normal ones. Alkenes are manufactured by cracking larger alkane molecules. State the source of the large alkane molecules using cracking: petroleum. State two conditions needed for cracking large alkane molecules: high temperature and a catalyst. When one molecule of dodecane, C12H26, is cracked, 3 molecules of B1ene and one other product are formed. Use molecular formula to complete a simple equation for this reaction. So 3C4H8, so because it said 3 molecules, but1ene, we can use a general formula for CnH2n, basically alkenes. So C4, but is 4 prefix, and H8, 2 times 4 is 8. So 3 times 4, 12, so there's no carbon here, must be hydrogen. Suggest a type of chemical reaction which happens during cracking. This is a tough one. It's hard to recall at this stage when you're at this point of the paper. So suggest a type of chemical reaction which happens during cracking. Combustion, no. Exothermic, not really. Endothermic, not really. You're not sure. Place your bet on thermal decomposition because it literally shows A equals to B plus C type of equation. Propene will undergo polymerization. Suggest a name with a polymer formed from propene. Alkene, so that means going to be addition polymerization. That's going to be polypropene. Draw a part of this polymer molecule to show 3 repeat units. So basically we draw it first out. So that's going to be C double bond CH, CH3, H, CH3. And then what we do is we take this part and move it here. So that's going to be CH3. And we move this part, it's going to be CH, CH3. And then we remove this line. And then we draw 3 of these, and you have to remember that you need to do the continuation because repeat units. It hasn't really ended. We need to show that it's continuous and it hasn't ended because repeated. So say the type of polymerization propene undergoes addition. Question 6. Polyamides and polyesters are polymers. Polyamides can occur naturally or can be manufactured. Part of the structure of polyamide is shown in figure 6.1. On figure 6.1, draw a circle around one amide linkage. So amide linkage N with C. So this one. Complete figure 6.2 to show the structures of the two monomers needed to make the polymer figure 6.1. As you can see, the colors need to represent the same atoms. C double bond O, OH, carboxyl group, and we got the amine group, which is NH2. Name the other product formed in this polymerization. This polymerization is condensation polymerization, so that means water has to be the byproduct. Say the term given to natural polyamides. Biology reference, which is protein. Name the type of monomers which are used to make natural polyamides. Amino acids. One of the monomers which forms part of a natural polyamide has 3 carbon atoms. Complete figure 6.3. Show the display formula of this monomer. So it's going to be C double bond O, OH, carboxyl group, amide group, and the R group. So this time, what you would normally see here would just be an R. That would be the general structure. But since it said here 3 carbon atoms, so that means there's a carbon atom here, there's a carbon atom here. So where would the third carbon atom be? Should be in the R1, because instead of the R, there's actually another compound. There's a whole molecule. So instead of the R, we're just going to go C, and usually the C bonds with hydrogen atoms. That's going to be your R, that's going to be your answer. This is a bit of a tough question because this is actually not really usual or common for exam questions to give. Alright, so PET is a polyester. Name the 2 types of monomers, monomer molecules needed to make polyesters. It's going to be diol and dicarboxylic acids. Alright, draw part of the structure of PET which shows 2 repeat units. Show all of the atoms and all of the bonds in the linkages. You got O, O, C double bond O, C double bond O, 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 C double bond O, C double bond O. It literally shows you here diol if you know diol and dicarboxylic acids. Alright, we have finished the past papers. The past paper, unfortunately, which is great. I mean, honestly, the questions didn't really differ that much. But as you can see here, instead of the usual pattern, like instead of numbers or you just name you just write the like for example ethene or ethanol, you use the letters. So this was a trick. So a mistake some students would do that are panicked or stressful, they could say the name of the formula. They could write the name of the formula instead of the letter reference here, A, B, C, D, F, G, H, I. And also another mistake would be to mess up the epoxide with the cryolite. I mean, this was a fairly easy question. I mean, the first and the second question. The first question does have a tricky question, which is undergoes a substitution reaction with alkanes. Quite some questions that are easily mistakable, like some could forget the answer. And this one, like another mistake that students would do is saying instead of mobile ions, they would say mobile electrons, which is really, really wrong. Because ions, because it's a mixture, but if it's electrons, if it's a metal, that would be electrons, yes. And other than that, they could also say, for example, Al3 plus 3E minus equals to 3Al. It's actually only one aluminum, as you can see here. There's no coefficient here. Write the number of electrons needed to balance, and yeah, that was fairly simple. Say why the process of anodes and oxidation. Simple, losing electrons. Oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide, not oxygen. Carbon anions react with oxygen to form carbon dioxide due to high temperatures. And also another one would be this. Instead of saying resistance corrosion, you would say toxic, non-toxic. But non-toxic is not really an answer, except the marking scheme. So be safe with resistant to corrosion. Why is it resistant to corrosion? Aluminum has the thin protective layer of aluminum oxide, which is very unreactive. Aluminum reacts with fluorine to form the ionic compound aluminum fluoride. Drawing question. You got the electrons. Do not forget to do the outer electrons instead of the thinking you're drawing the inner one and then the outer one. Yeah, and also the charges. And also this one, this tricky question that says suggests in terms of attractions between particles why these chlorides have low melting points. So you have to say this. They both have weak intermolecular force of attraction between molecules and weak also. It's honestly fairly simple. Like there's just a few tricky questions and few questions. Actually, one question that this one. This would be a question that people that really memorize the ions, the anions, the cation stable, and the flame test would have an advantage to this question because they know that since it's Br, it's gonna be cream. And tackling equations. Name the salt dissolved in the filter in step 3. She should have an understanding that not just the ionic equation doesn't show all the compounds that are made, it just shows the important one, the main one, which is silver bromide here, and forgets sodium ethanol. And separation techniques, that's an important part. Yes, suggest a type of chemical reaction which happens during cracking. That would be thermal decomposition. That would be a tough one. And I'd say too that VI, this question was kind of difficult because it's not really shown in the it's not really known that students should know that R R has the CH3. So yeah, this is kind of challenging. Diol dicarboxylic acids. And yeah, fairly it was alright. It was alright. Alright, thank you very much for staying until now to hear my review, and goodbye. See you next time.